All right, guys. So in this case, we are not going to waste our time. We're gonna quickly go through this question paper, which was actually from the KZN province. As we can have, as you can see, guys, we had the previous paper from the same province, but it was for 2023. So as a request that you had, guys, for us to work with 2024 March test so that we can see how it was. So this is it, guys. We had this one, max, it was 75 and time 1.5 hours. So guys, we're not gonna waste our time. Like I said, gonna quickly go through the questions. Make sure that you do read the instructions and information that you're given, especially rounding off of answers to two decimal place unless stated otherwise. So this is what we had. And on question number 1, you were given indicate whether each of the following numbers is rational or irrational. Indicate whether it is or not. So with the questions, guys, that we have done and introductions of this, I think now, guys, we are together. On a rational number, what you just need, guys, is to have what? A over B. That's a rational, where A and B are whole numbers, which can be, as long as you can have it as a fraction like this, and B is not equal, take note, B is not supposed to be equal to 0. Irrational numbers, those are the ones that if you are to simplify, we cannot, guys, evaluate them exactly. We cannot have an exact figure. Those are the square roots of numbers which are not perfect squares. The square root of numbers which are not perfect squares. They can be simplified, but they are not perfect squares. Or the cube root of numbers which are not perfect cubes. When I'm saying a perfect cube, I'm referring to numbers such as 8, 27. These are the perfect cubes, but which is not. So when I'm saying which is not, it can be a 9, it can be a 7. This also is part of what the irrational numbers. As long we can see, we can have it on our calculator. Let's say the square root of 3. Look at this, guys. Cannot be simplified. That's an irrational number. Whenever you try to simplify it, it remains there under the square root. If you have it as a decimal, it's going to be an endless decimal. All right. So in this case, let us quickly go through square root of 15. Where is it going to lie? So as you can see, guys, this one is an irrational number. We cannot simplify this one. We can also use our calculators to simplify that. Square root of 15, as you can see, it remains like that. If we change to a decimal, look, it's not even end. All right. 2,5 on question 1.12. It's already, guys, it's already simplified. It's already in simplest form. So it's a rational number. Can also be expressed in the form of A over B. If you want, you can just take your calculator. 2,5 is equal to, as we can see, 5 over 2 as a fraction, 5 over 2. So meaning to say this one is a rational. All right, the cube root of 8. Take note, 8 is a perfect cube. So when it is a perfect cube, it means whatever that you're going to obtain there is going to be what? A rational. Remember, I said irrational. These are the cube root of those numbers which are not perfect cubes. They are not. But this one, it's a perfect cube. But you can also use your calculator to verify that. All right. So the cube root, we have it. Let me just try to increase, guys. This one is 2. All right. Let me here. So as we can see, the cube root here. So it's going to be shift here. The cube root of 8 is equal to what? 2. So 2 is a whole number. 2 can be written as what? 2 over 1. So that's a what? A rational number, that case. All right. So this is what we have. Then 2,33333. A recurring decimal is what? Is a rational number, guys. All right. A recurring. It's just 2,333. Just if you're given something like that, we know it can be written as a fraction. This is the question that they're asking you, similar to that on 1.1, on 1.3 here. Write down this as a what? As a fraction. So once you're given a recurring, do not even worry. Just know that one is what? It's a rational because it's going to be a fraction at the end. Remember, it's something that you're also supposed to know how to express it as a fraction. All right. Anyways, guys, these were free marks. 1.2, write down two rational numbers. But these rational numbers are between what? Square root of 2 and square root of 10. Show calculations. Like I said, guys, you are already given a square root. Square root. So you must deal with the perfect squares. Look for perfect squares. We're talking of two rational numbers, guys. Between what? Between these two. So we are having, that's 1.2, between square root of 2 and what? And square root of 10. Just look for perfect squares. Why? Because you are having a square root. If it was a cube root, you look for perfect cubes. But in this case, you look for what? Perfect squares. Perfect squares. So the question is, the perfect squares that we have are being affected by what? These numbers. In between these numbers. 2 and what? 2 and 10. Do we have any perfect squares between these two that we can relate? That can give us, because we know, guys, square root of 10 is what? You can just use your calculator to see that square root of 10 is what? As we can see, guys, this is what? 3 comma something. 3 comma that. From where? From 9. 3 squared is 9. So 3 comma, guys, we know that it's something that is bigger than that. So the question is, write down two rational numbers between these. The rational number, I want you to be careful there because they are between these. So that's why I'm saying the perfect squares that you're looking for, they're supposed to be in between. Because they're saying between. So which number can we use? This square root of 10 is 3 comma some. It's a number which is actually, when it is a square root, it's a number which is actually greater than the square root, bigger than the square root of 9. What about the square root of 2? It's actually a number that is smaller than 2. So you're supposed to look for what? For 4. Square root of 4 is 2. Numbers between, perfect squares between. You're going to look 1, 2, all right, sorry, perfect squares, 1, 4, 9, 16, and so on. These are your perfect squares. But as you have them, guys, just look for numbers that are in between. In between 2 and what? 2 and 10. So that, guys, you can see that this is where we're going to have our range. What is the square root of 4? All right? What is the square root of 4? And we have the square root of 9. Square root of 9. The square root of 4 is what? Is 2. This is 2. What about the square root of 9? It's 3. So this is, we're saying the two rational numbers that we have between these is going to be what? 2 and 3. So when you're given this condition, guys, let's look for the perfect squares between those numbers that you're given. They won't even go beyond that. Okay, they won't even go beyond that. At this question, guys, I think explaining this question can even confuse you guys because we are now used to that one. All right, 1.3. Write down this as a fraction. All right, so remember, when we are to convert our recurring decimal to a fraction, we are given 0, 0,1. Okay, that's 0, 0,1111, and so on and so on. So I said, guys, you can simply let x represent the decimal that you're given. all right, which is 0.11 and so on. And on that decimal, okay, this decimal that we are seeing, it was supposed to be actually be given like this 0.1. All right, then they put a dot there on top. It's the same thing, guys. It's showing that it's continuous, that part, that number that you're given. How many digits that we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. So we're gonna write, guys, 8 of them. Just choose even 4 or 3, all right? For your calculations, guys. So I'm just gonna write, let x be equal to 0.1111, all right? So multiply this by 10, 100, this, until we get something that when we are to subtract or to evaluate, we are going to have the same thing here. All right, so I want you to consider in terms of the digits that we have here. Let's say we are to multiply this one by 10. Our equation 1. This is our equation 1, guys, all right? You multiply by 10. It's going to be 10 times x, which is 10x is equal to, all right, I just want you to take these digits as they are, only 0.11. Therefore, I'm just going to use 4. All right, let's say you multiply by 10 like this. This is what you're going to get. 1.111. So I want you to see what is happening there. All right. Sorry, we multiplied there and we got 1.111 like this. There are 3 digits. Not to say that there are 3. There were so many digits that we neglected there. So those digits, they're still here, and so on and so on. The 1, and so on, they're still there. And we can see that we have the same thing, guys. Same digits here, same values that are after the comma here. These values after the comma, these ones are the same. So once we have this same order, same values, same order, same values, same as they are, you can subtract your equations. Like I said, we started with this one as our equation 1. We have this one as our equation 2. So you can subtract, guys, right? Let me just write the 2 that we are used to, some of us. All right. So what are we going to have then? Simply subtract. It's going to be equation 2 minus equation 1. It's up to you. Equation 1 minus equation 2 is up to you. So here I'm just going to target what? A bigger value. So I'm going to use equation 2 minus equation 1. All right. So anyways, guys, and any way that you want. Any way that you want. All right. So if I'm going to subtract, it's going to be 10x minus what? X. So that's 10x minus x is equal to, I subtract also this 1.111 minus 0.1111 like this. So as you can see, guys, these ones and these ones, we're going to cancel. Here we're going to have 10 minus 1, which is 9x. These ones, guys, we're going to cancel. So it's simply 1 minus 0 here, which is 1. Or you can just use your calculator. But as you are using your calculator, just target a few values there. Like we had this as 1.1111. The 4 digits only, all right? 0.4 digits also after the comma. Okay, the values there after the comma, make sure they are 4, like that. So you're going to get a 1. Same thing that we had here. So you can see that divide by 9, you're going to have the value of x. Just like that. So this is, this was going to give us our x, which is 1/9. So as you can see, guys, we have it as a fraction. That was the question. We are supposed to have this as a what? As a fraction. We are supposed to have this as a fraction at the end. So simple like that. This one, guys, do as many questions as you can. Factorize the following expressions fully. All right, we are supposed to factorize these expressions that we are given fully. Okay, so what can we do? That's 1.4. All right, so I'm going to take the first part, which is 1.41 x cubed minus 8. All right, so remember, guys, the part of your factorization as we had these sum and difference of 2 cubes. All right, let me just try and reduce a little bit. So like I was saying, we had a part when you're working with the sum and difference of two cubes. All right, when you're given something of this nature. So this is 1,41. Remember, x cubed minus 8. I said if we are given an expression which is of this nature, x cubed minus y cubed, that's difference of what? Two cubes, ones that are raised to the exponent of 3 like that. So how do we factorize this? We said it's going to be first minus last, x minus y, into x squared plus xy plus y squared. This is how we're going to simplify. So as long I have, what is important here is having a term raised to the exponent of 3 minus another one, first, last. So here we can see the x to the exponent of what? Of 3. But what about 8? Can it be written as a number to the exponent of 3? That is the question. Yes. So how can we note that? The cube root of 8. For you to simply see that, because we are talking about what, guys? To the exponent of 3. So for us to know which number, just find its cube root. What is the cube root of what? Of 8. The cube root of 8 is 2. So knowing this, guys, is important. So you know that if you take 2, raise it to the exponent of 3, you obtain what? 8. You obtain 8. So that's the 8 that we are seeing here. So it's the same thing here as writing this as x to the exponent of 3 minus the 8 written as what? A number to the exponent of 3, which is what? 2 to the exponent of 3. So that we can properly see what is representing our first term as x, our last term as what? As y. From this factorization of the difference of what? Of two cubes. How are we going to factorize? You know that from this, we are going to take this one as what? First minus last, x minus, so that's first minus last. So that's first minus last, x minus what? X minus 2 into what? X squared, the first term squared, x squared. So as you can see, the first term, guys, is x, so it's going to be x squared plus xy plus, take note, it's gonna change to plus. So it's gonna be plus x. Our x is the first term, and y is representing what? The last term, which is 2. So multiplying these, guys, we're going to have what? Plus 2x. 2 times x, that's gonna be plus 2x. All right. And we have what? The last term plus y squared plus. So that's plus the last term squared. Our last term is 2. So that's 2 squared, which is going to be plus 4. So this is factorized fully using this concept of our difference of two cubes. So just like that. If it was a sum, because it can be a sum, it does not mean that always you're going to be given a difference. Remember, a sum, x cubed plus y cubed is equal to what? It's going to add first, x plus 1. As it is here, it's going to add, but it changes the sign here to a negative, just like here, a negative to a positive. That's the only part that's going to affect. So it's going to be x squared minus xy plus y squared. So plus here, a minus there. This is the concept. So do revise, guys, as many questions as you can. All right, let's consider another part and see again on our factorization on 1.42. So this is what you're given, and that is 3 marks, all right? 1.42, again to factorize. So there we are given 4 terms. When we are given 4 terms, as we have there, 2x to the exponent of 3 plus x squared minus 6x minus 3. Like when you are given 4 terms, 1, 2, 3, 4, like this, Guys, whenever you've got this, the first thing that you're supposed to think of is factorization by what? By grouping. That's the first thing that you're supposed to think of. Given 4 terms, by grouping, where we can group them into 2 like this. The first 2 terms and the last 2 terms. And we check if there is anything common between the first 2. We can see that x is common. Here, that there's a 3. So we can see that this can be factorized. You have to test to see, okay, if I group them into 2 as they are like this, can it be factorized? Yes, it can. So for the first 2, what is the highest common factor between these 2 terms? The highest common factor is going to be what? X squared, the one that has got the smaller exponent, the smallest exponent. So that's x squared into what? 2x squared, 2x cubed divided to x squared. So how many are there here? 2 into these ones, which are 3. We're going to remain with 1. So that's going to be 2x, x squared and x squared, guys. These ones are exactly the same exponent. So just going to cancel and you get a positive 1 there. As we can see, we have a positive. So I said, guys, you are supposed to have the same bracket as you are applying your factorization by grouping. This bracket, as you see it here, it is supposed to be exactly the same as the bracket that we are going to obtain after factoring out what is common here. We are supposed to have the same bracket. So that is where we are supposed to test now to say, okay, between these 2 numbers, we can say that 3 is the highest common factor between what? 6 and 3. But because there is a sign to be considered, is it going to be a -3 or is it going to be a +3? If you do not know, test that part. How do we test? We simply put, okay, if we say we're going to factor out a -3, what's going to happen? -6 divided by -3, that's a positive 2x, negative cancels. -3 divided to -3, that's a positive, negative cancels. You get what? Positive 1. Exactly the same as what we want. Okay, let's say we factored out a plus. Let's say it was a +3 that we factored. It was going to be -6 divided to 3. Minus and a plus will give us a negative. -3 to +3, it was going to give us a -1. Minus and a positive is what? A minus. The bracket is not the same as this one. Is not the same because this one is having positive. So you'll be forced to factor out again the negative that you see in case that you did that. But guys, we can see that the proper part was simply going to factor out what? A -3. And we factor out a -3, the brackets will be the same. So that is it, guys. As we saw, if we factor out -3, we're going to have the same bracket of 2x plus 1. So this is exactly what we want. Same bracket. So having this same bracket, as we can see, we can factor it out because it's common. Again, this bracket is common. So we are going to factor that bracket out. The bracket of 2x plus 1, when it is factored out, what are we going to remain with? If we factor it out here, we're going to remain with x squared into another bracket. This one, we're going to remain with a -3 into another bracket. So also test at the end, the x squared -3 there, because there's a perfect square here. Check if this one is also a perfect square. But in our case, it's not. Why am I saying you're supposed to check? Because there's a possibility of having a difference of 2 squares where you're supposed to apply again factorization of that difference of 2 squares. But in our case, everything was done. Everything was proper like this. We are done. All right. Anyways, guys, let us see another part, which is 1.43. Again, it is to factorize x to the exponent of 4 minus 16. X to the exponent of 4 minus 16. All right, let's see what we are given there. So if you are to consider this question, guys, no problem. That's 1.43. x to the exponent of 4 minus 16. We cannot put it under the difference of 2 cubes. Those ones that we had because we're talking about to the exponent of 3. Here there's a 4. So which one can we target? 4 is an even number, this one. It is an even power, an even exponent that we are given. So it is easier for us to rewrite it back to the difference of 2 squares. Because we are working with what? 2. 2. Remember, difference of 2 squares. A squared minus B squared. A squared minus B squared is equal to what? A minus B into A plus B. So we are focusing there with the square, the square. So that's why I'm talking about an even power. If we have an even power, then it's easier for us to rewrite that one as to the exponent of 2. So how can we have this? It's going to be x to the exponent of what? So this is your question, guys. You're asking yourself, it's going to be x to the exponent of what here? But what is it that we are supposed to have at the end? Being raised to the exponent of 2. What we want, guys, is to have what? The exponent of 2. So at the end, is going to be raised to the exponent of 2. So which exponent here x must have, but remaining or having the original question as it was before? We are not supposed to change the meaning of the question. So which exponent must you put here? That's a 2. 2 times 2, that's a 4. Let's say I do not know this. How can I find this? From our laws of exponents, we know that the exponent that I'm supposed to have here that I do not know, and this one together, what is the combination there according to the law? They can be multiplied together. So is the exponent that I do not know times what? Times 2. To give us what? Originally what we are given, which is 4. So what is that exponent that I do not know? Just like that, we can have it as a 2. Guys, this one is direct, isn't it? All right, anyways, let's move on to the 16. So the 16 can be written as what? That's in the certain number to the exponent of 2. So 16, just find its square root, a number, this one. Just find square root of 16. That's what's going to be 4. So it can be written as 4 to the exponent of 2. So this is what we wanted, guys. We have a certain part raised to the exponent of 2. The whole of this part here, x squared, is raised to the exponent of 2. And also this one is raised to the exponent of 2. Once we see this, we can apply our difference of 2 squares, which states that we're going to have a minus b. So this is our a, guys. This is our b. The a minus, so we're going to have a minus b in one bracket. What is our a? X squared, as it is x squared minus b. What is our b? Our b is 4. Into what? A plus b, where a is what? X squared. Plus our b is what? Our b is 4. This is where you are. But as we can see, we have applied the difference of 2 squares properly, but still having another difference of 2 squares here. So check your answers. Do not just rush to underline to say I'm done. No, check again, especially for difference of 2 squares. Most cases, they will give you difference of 2 squares 2 times or even 3 times, depending with the question. So we have an x squared minus, where there's a minus, guys, there's no sum of 2 squares. There's only a difference. So we check the first bracket. Not this one. Here there's done because there's a positive there. There's no way you can factorize. All right? There's no sum of 2 squares. There's a difference of 2 squares. Take note. So this is x squared. So can this 4 be written as a number to the exponent of 2? Yes. 4 is same as what? 4 is same as what? As 2 squared. Remember that? So we're just going to have this one as what? As 2 squared. So meaning to say, again, our factorization was possible. A minus B, guys, just like the previous case. What is our A? That is our X minus our B, which is 2. We are referring to the part that is raised to the exponent of 2. Here, the X, and here the what? The 2. 2 squared. What is raised to the exponent of 2? So it was going to be X minus 2 into what? A plus B, which is X plus 2. Remember, I said this one cannot be factorized. So it will just remain as it is, X squared plus what? Plus 4. A sum of 2 squares cannot be factorized. It's not a sum of 2 cubes. Remember, the cubes, sum x cubed plus y cubed. This one, it can be factorized, but not for a sum of 2 squares like this. This one cannot. Remember your basics. All right. Anyways, guys, let us consider another part of our question. This is just for our revision purposes, guys. Make sure that you do revise as many questions as you can before you enter exam room to say, now I'm writing my test. Do revise as many questions. Simplify the following expressions fully 1.51. Simply expand the given brackets that we are given. There's 2 minus x into another bracket, which is x squared minus 2x plus 1. Remember your expansion of brackets as you are working with the brackets. There is a binomial there to a trinomial. So what are you going to do? Simply multiply each term. We've got 2x. It's going to expand everything in this bracket. We do the same thing with the minus 1. It multiplies each and every term in the second bracket, all right? So let us start with 2x. So that's 2x and x. This was going to give us 2x to the exponent of 3, x and x squared. So you're going to add. This is 1. So 1 plus 2, that's a 3. All right, the 2x to the minus 2x. So that was going to be minus 4 there, 2 times minus 2. Then x and x, that's x squared. You add also 1 plus 1. Then the 2x to the 1 there was going to be what? Positive 2x. You're multiplying to 1. So 1 does not have any effect. All right, it's a positive again. We are done with the 2x, guys. It multiplied everything. The same concept, minus 1 to x squared. This was going to be minus x squared. We do the same thing, the minus 1 to the minus, that's a positive. All right. Then minus 1 and positive 1, minus to a positive, that's a minus. So we're going to have negative 1. So let us collect our like terms as we have our terms. There is, all right, the x cubed is not affected, but the part of x squared, there is an x squared here. There is another x squared here. The part of x, there's this 2x and this 2x, all right? So x cubed and the minus 1, they are not affected. So I'm just going to write as it is 2x cubed. The part of x squared minus 4 minus x squared. This is same as minus 1x squared. So there's a minus 1 there. So minus 4 minus 1, that's minus 5x squared. Then moving on to x, this is 2x, this is 2x. So you add, you're going to obtain positive 4x, then a minus 1 on its own. You're done. So you've expanded the brackets. Just like that, guys, you are done. All right, let's consider another part, 1.52, expand again these brackets as they are. So it's either we are going to use the expansion of a binomial when squaring a binomial, guys, or just consider 2 brackets. Remember, when you square a binomial like this, a plus b squared, when you square it, it's going to be what? A squared plus 2ab plus b squared. Remember. So, meaning to say, we just need the first and last to know what is our first term And what is our last term? A and B. What is our first term here is 3x. And what is our last term is what? Is 5. So according to this concept, we are going to have a squared, the first term, our first term being squared. So that's 3 squared, which is what? Which is 9, and also x squared. X is raised to exponent of 2. Remember your concept of your laws of exponents. All right, so this is what we're going to have. Plus 2ab, on this other part, we are going to move plus 2ab. So it's just like plus 2, what is our a? Our a is what? 3x. And what is our b? Our b is 5. You multiply this as it is. 2 times 3 times 5. As it is. That was going to give us 30. So that's plus 30x. You're done. Plus b squared. The last part, plus b squared. Our b is what? 5. And 5 squared is what? 25. Knowing this, guys, makes it easier in your expansion. But let's say you do not know this, guys, right? Do not panic. You can just expand as usual. As usual. You have your 2 brackets, all right? The first bracket is what? 3x plus 5. Because the squared there means that there are 2. You have another one, 3x plus 5. So in this case, you can simply apply your FOIL method. Or just like the previous case, you just multiply 3x, has to multiply everything. So it's 3x times 3x in the second bracket. 3 times 3, that's going to be 9x squared. The 3x multiplies the 5 here. So that's 3 times 5, which is what? 15. So it's going to be positive 15x. You are done with the 3x. You move on to the positive 5. So it's positive 5 times 3, which is what? 15. That's positive 15x. Then you move on positive 5 and the positive 5, which is going to give us what? Positive 25. So from this, we can collect our like terms, these terms in the middle. So what are we going to have? 9x squared 15 plus 15, that's a positive 30. So this is what you're going to have at the end, just like that. So meaning to say, as you are working with expansion of brackets, it is in your hands way that you're gonna simplify that. You choose how to expand the way that you understand. All right, looking into question 1.53, we were given to simplify 2 to the exponent of x minus 2 to the exponent of x minus 2 like this, everything over 2 to the exponent of x plus 1 minus 2 to the exponent of x. So guys, this one we can simply consider our terms separately. 2 to the exponent of x looks common here. This one is something about this 2 to the exponent of x. So we have to separate that so that we can factor it out. So we've got 2 raised to the exponent of x minus, what does it mean here? We've got 2 to the exponent of x times 2 to the exponent of minus 2. Remember I said when separating, guys, just put a product. You separate the sign as it is. As long as you put a product here at times, you separate the sign as it. If it is a plus, you write a plus as it is. If it is a minus as it is. All right? Just like here, guys. Here, I want you to see here. 2 to the exponent of x times 2 to the exponent of 1. Do not even worry, guys. To say there's a minus there, what? Remember, when you multiply, you add. If you add this, x plus minus 2, you get that one, x minus 2. So do not even worry about that. Minus 2 to the exponent of x, there's nothing that we can do, just like the previous part that we had. So as we can see, we can properly see that the 2 to the exponent of x here, 2 to the exponent of x here, 2 to the exponent of x, also it is there. So what can we do? We can factor it out. So as we factor this one out, know that where we do not see a number there in front or back of that 2 to the exponent of x, there is a 1 there. So we must know that there's a 1 there. Same thing here. We have got a number there. All right. So that when we are to factor out the 2 to the exponent of x, this one, 2 to the exponent of x, you remove it there. What do you remain with? You remain with a 1. So that's 1 minus. You factor this one. What do you remain with here? 2 to the exponent of minus 2. All right, let's move on to another part here. 2 to the exponent of x again is common. You factor it out. What are you going to remain with? That's 2 to the exponent of x into what? You remain with this one. 2 to the exponent of 1 minus. It is common here again. We factor it out. That's a minus 1 that you're going to remain with. So these terms can be terminated. They can be cancelled. This is the product. This term can cancel to this one, can cancel it. They're the same. So just like we have got a 1 and we have got a 1. So 1 times this, guys, these brackets are simply the same. From our laws of exponents, a negative exponent there, same as what? 1 over 2 to the exponent of 2, which is 1 over 4. So we've got 1 minus 1 over 4. Everything over what? 2 to the exponent of 1, which is 2 minus 1. So this is what we're going to have, guys. We can subtract 1 minus 2 over 3. 1 minus 1 over 4, which is 3 over 4. Some of you guys are saying, let me subtract it properly. Do not use a calculator. All right. 1 as a fraction in the denominator of 4 is same as what? 4 over 4 minus 1 over 4. Because the denominators are the same, we can subtract the numerators 4 minus 1, which is simply going to give us 3 over that same denominator, which is 4. So it's going to be 3 over 4. So this is what we have, guys. Or this is what we're going to have from the numerator. You're going to get what? 3 over 4. But everything is over what? There is 2 minus 1. And 2 minus 1 is what? Is 1. Guys, dividing by 1. 2 over 1 is what? It's 1. 3 over 1 is what? Sorry, this one is 2. 2 over 1 is 2. 3 over 1 is what? It's 3. Anything, if it is 4 over 1, it's going to give you a 4. So what about this 3 over 4? Divided to this one. So it's just going to remain as what? 3 over 4, as it is. So dividing by 1 does not affect our question. Just remains as it is, all right? Does not even affect your question. Does not even affect your question. So this is how you're going to have it, guys, in this simplification. I don't know, some of you can introduce the K method. Guys, the K method, guys, I think like now it's being taken too much. But it's even fine. But you can even use that, guys. By the way that I'm seeing even the request there, I'm seeing like we are taking the K method that much, guys. All right, 1.54, simplify this, and that was 5 marks. Addition and subtraction of your fractions. How do you add, subtract, given fractions? That is the question to be considered. All right, anyways, guys, we're gonna consider our question, which was 1.54. So our question 1.54, we are given 3 over a minus 4 like this. That's plus 2 over, this is a plus 3 minus 21 over what? A squared minus a minus 12. All right, this was a nice fraction. Why am I saying it's a nice fraction? Because of the factorization there, it was easier, guys. Anyways, you can see that the first part, these are just linear, nothing to be factored out. You just rewrite as it is. 3 over a minus 4 plus the same here is just a linear. There's nothing that we can do, just rewrite as it is. Minus the quadratic there, where we have got the a squared. There is a need for us to factorize. And the best part, guys, the coefficient of a squared is what? Is 1. Take advantage of that, guys. Just put brackets there. Two of them, you put an A here. Because A times A is what? A squared. But you have to ask yourself now the factors or the products. All right. Okay, let me increase this one. I've reduced to be like a pen. All right. I'm supposed to have it like this, guys. No problem. So we need the products there. The factors of what? Negative 12. Negative 12. But as we have it as a negative 12, these factors must add up to this one, the coefficient of A, which is negative 1. They must add up to negative 1. What am I trying to say? Factors of negative 12. As we consider 4 and 3 to have a negative 12, we must have 1 being negative. Like this. 1 must be negative. If you say I have a 6 and a 2, 1 must be negative. These are the products that I'm talking about, the factors that I'm talking about. But we need that condition when we add, we get a -1. So guys, here, the difference between these two numbers, guys, there's a difference of 4 there, whether it's going to be -4 or +4. So let's not focus with these ones. One is something else there. But from 4 and 3, we can see that there's a difference of 1 there. But we need exactly where we're going to get a -1. Where? If we add these two, negative 4 plus 3, that's -1. This is what we want, guys, the first part. What about here if we add these ones? 4 plus -3, that's a +1. This one is a +1. Guys, your calculator is there. You can even use your calculator. 4 plus -3 like this. It will give you a +1, not a minus. Not a minus. The one that will give you a minus is this one, the first one. So these are the ones that we need here. A -4 and what? A +3 like this. So with these, we can simplify our brackets, guys. I mean, our fractions. Why? Here we just have to look for the LCD of these denominators, as we can see properly, guys. A -4 is there. A plus 3 is also there here. So we are just going to take these ones as they are. As they are. They contain all our expressions in this, in the denominators. All of them, they are contained here. All of them. So it's called the lowest common denominator, the lowest common multiple. It must contain all. So if there is one which is missing here, like for an example, we put it like this. We cannot say this or else because we do not have a -4, which is there here. We must have exactly all these in the denominator. So a -4, it is there. All right. A -4 is there. A plus 3, we see it there. So that is the condition. So let's simplify. We're going to divide our LCD to this denominator, the first one. So as you can see, this one and this one was going to cancel. But I say do not cancel. Just assume as if you are canceling. So you're going to remain with what? A plus 3, which you multiply to the numerator. So that's 3 into A plus 3. So the case is, we have A plus 3. It's going to cancel with A plus 3. What's going to remain? A minus 4. The A minus 4 that is remaining will be multiplied to that number, but do not forget its sign. So it's going to be plus 2 into what? Remember, A plus 3 canceled. So you're going to remain with A minus 4. These ones, they are exactly the same. So meaning say as they divide, we're going to cancel and have a 1. So it's going to be -21 times 1 because they're going to cancel as they are. So this is what you have on your numerator. And we can expand our brackets, collect like terms as usual. Let us simplify here. This one here, and okay, it's just a 1. Not a problem. Let's expand. So that's 3 times A. What we're going to have? 3A. 3 times 3, which is a +9. +2 times A, that's +2A. Positive 2 and negative 4, that's a negative 8. Negative 21 times 1, that's negative 21. Everything over the denominator as it is. You maintain it throughout. You maintain that. But simplify wherever it is possible the numerator. There is a 3a, there is a 2a here. These are like terms. So I can simply add these two. What am I going to have? 3 plus 2, that's 5. So I'm going to have 5a. The remaining numbers simplify as they are. We can even use our calculator to simplify these numbers. Okay, no problem. That was 9 minus 8, and this one was what? Negative 21 minus 21. So that was going to give us negative 20. So we've got negative 20 over the two brackets, a minus 4 into what? Into a plus 3, like this. As it is from the what? The given denominators that we, from the given denominator. This numerator as it is can be simplified. Okay, what can we do now? Factorization. We are guys, we are done. Like at this stage, we were supposed to underline our answer here, but test if we can have this part factorized. Can we factorize? 5 is common from that, so you can factor out 5. 5a divided by 5, that's a, minus 20 divided by 5, that's 4. So this is what you're going to have. The numerator was going to be 5 into a minus 4. The denominator, as it is, a minus 4, a plus 3. But as we can see, these are exactly the same, and it's a product. So they can be cancelled. So we have got what? 1 here, 1 there. So 5 times 1, that was going to give us 5 over 1 times this bracket as it is. It was just going to remain as what? As a plus 3. So that's 5 over a plus 3 as it is. Just like that. Just like that. You see, guys. You see your mathematics. You see your mathematics, guys. It's nothing, guys. Do as many questions as you can. They are scaring you, guys. At school there, they are scaring you. Wherever you go, the community is scaring you. Mathematics is difficult. No, it's not. Give it time. Give it time. You'll see that there is nothing at all. As you can see, there's nothing. All these calculations, guys, you can do them as much as you can. You as an individual can do them as much as you can. Revise your question papers. Do as many revisions. Basics. Know the basics, guys. Go through the basics. All right. So without wasting time, let us consider this part. Sorry for this, guys. I'm just going to do this. I did not want to do it, but I'm just forced. But it's not a problem. This is what we are given here. Number 2, solve for x, 2.1. So we're back to equations. All right. So the first one, it was direct 2 brackets on 2.11. We know that when we are given this condition, guys, where we've got 2 brackets, we're going to simply equate each of these to 0, each to 0. So it's going to be x plus 3 to 0, or the bracket of what? X minus 1 must be equal to 0. So let's take the 3 to the other side. It was going to be what? A negative. Remember, it's a positive. So it's going to be a negative. The number changes the sign. A negative there was going to be what? A positive. So this is what you're going to have for 2 marks. All right. Solve this one. So we are not even told, guys, like 2 decimal places or what. We are actually like, when it is 2 decimal places, we know, guys. This one you're not even told. So it means we can use our factorization. When it is like that, we're going to test factorization. Also use your quadratic formula if you want to apply the quadratic formula. All right. So I'm just going to use both. Let me have my equation here, this side. So guys, very sorry for this. I just need a space where we can have our question done properly without limiting the explanation due to the page that will be given. That's why I'm doing this. Anyways, let's see. So we are given That's 2x squared minus 5x plus 2, which is equal to 0. So remember, I explained your quadratic formula, factorization, and that factorization is going to depend with the way, guys. Your factorization, I said, if you are someone who is doing factorization, stick to the methods that you understand. You know that you're going to have two brackets at the end because here the coefficient of x squared is not 1. So we can apply different ways according to what you understand. Your teacher can give you this one, guys. It's up to you. So I explained also about this cheat method. I don't know if I explained this one also to you guys, and even the grade 11s, where we can use or apply this cheat method, 2x squared minus 5x plus 2 like this. We take out the 2 here to multiply the last term. All right. So this is how you're going to take it. We steal it out to multiply the last term. So it's going to be written as x squared. Remember, we have removed it. It's no longer there. So it's now x squared minus 5x. 2 times 2, that's a 4. If you multiply these two, you're going to get a 4. So as you can see, this can be factorized. I said you're going to factorize this. All right. As we can have 2, the coefficient of x squared, which is 1. So you're going to put x, you put x, you are used to this one, where you're going to ask yourself, what are the products of what? Of 4, but they must add up to -5. So as you can see, guys, the 4 and the 5, the number is already there, 4 and 1. But to get a -5, these must be negative. Negative times negative, still a positive, not affected. But on adding -4 plus -1 is going to give you a -5. So that's a -4 and a -1. These two numbers. A -4 and what? A -1. What about the 2 that we stole and multiply there? Remember that it is part of our question. We are supposed to bring it back. Wherever we see x, we put that 2, we put that 2. Then factor out what is common in these two brackets. Whatever that is common, the first bracket, 2 is common. So we can factor out that 2x divided by 2, that's x, -4 divided by 2, that's -2. And this bracket, there's nothing common. It remains as it is. The 2 that we factored out there becomes useless. It's no longer part of our bracket. It's no longer part of our solution, So this is part of our factorization. The brackets that you're supposed to have here, according to your own way, are these two. X minus 2 and 2x minus 1. So guys, there, it is in your hands. But after that, you can solve just like the previous case. When we are given a 0 like this, the product, one of these must be equal to 0. So this is the condition. So guys, make sure that you know the type of factorization that you're going to apply. And after that, you're going to solve. So what you're going to have, negative to the other side was going to be a positive. So that's a positive 2. Or our x is going to be what? Take note, -1 to the other side will give you a positive. But remember, it was like 2x. So you're going to definitely have to divide by 2 like this. So our x was going to be what? 1/2. So this is what we have. X is 1/2. And here, x is what? X is 2. So like I said, you can use your factorization like this, or the use of the quadratic formula. It's applicable in your syllabus. As long you do know your quadratic formula. So remember your formula, x is equal to what? -b plus or minus the square root of b squared minus 4ac, everything over 2a, from our quadratic equation, which is of the format ax squared plus bx plus c is equal to 0. So a is the coefficient of what? X squared. B is the coefficient of what? The coefficient of x. And C is the constant, as we can see from our equation. So thus, we can substitute as they are. X is equal to minus, what is our B? A -5. So it's -5 plus or minus the square root of b squared, which is minus 5 squared, minus 4 times our a, which is 2, and our c, which is what? Which is 2. So everything is over what? 2 times a. Our a is what? Is 2. So we can easily or simplify this, guys, as we can see. That's going to be minus to a minus. That's positive 5 plus or minus. I told you guys, just try to simplify this part under the square root. Yes, you can use your calculator. I'm not saying it's wrong, but just try to simplify those values that we are seeing under the square root. It can be very, very wise for you guys to do that. All right. So guys, my calculator is just misbehaving. I need it to be somewhere. All right, no problem. I'm just gonna use those values, guys. It's gonna take my time to fix that one. All right, we saw that there's a minus 5 squared, minus, there was 4 times 2 times 3. All right, so that was gonna give us a 1. No. That's a 2, not a 3 here. This one is a 2, so it's gonna give us a 9. All right, so that was gonna give us a 9 here. Everything over 2 times 2, which is what? Which is a 4. 2 times 2, that's a 4. So using our calculator again at once, now we can simplify this. Just put a fraction 5 plus the square root of 9. At least let the one that is marking your paper know this value under, to see that value under the square root. It is important, guys, in your mathematics. The stage marks also, so that's going to be 2 there. So x is equal to 2, or x is equal to what? Yeah, sometimes, guys, most of you there, you just simplify it once because your teacher will be telling you, just use your calculator. Your teachers, they want calculators, most of them. They just want to use a calculator. All right, wherever they see maths, they think maths is it's calculator. Maths is not calculator, guys. Maths is maths. Calculator is calculator. Anyways, guys, this is how you're going to have your questions. So do make sure that you work out as many questions as you can. That's for the basics of your revisions. So like I said, this is your quadratic formula. If you were to use the quadratic formula. All right, let's consider another part, which is again on solving, but that's an exponent that we are given there. 2 to the exponent of, all right, 3, and this is, all right, so this is just direct, guys. 2 to the exponent of what? 2 to the exponent of 3x minus 1 is equal to 64. So can you write 64 in the base of 2? Yes, that's 2 to the exponent of a 6. Or you can test. 64 is equal to, then shift fact, right? On your calculator, shift fact, 2 to the exponent of what? Of 6. So thus we can use that one as 2 to the exponent of 6. So this is 2 to the exponent of 3x minus 1 equal to 2 to the exponent of 6, where we do understand that if these bases are the same, we can simply equate our exponents. That's therefore 3x minus 1 is equal to 6. That's an equation, a linear equation. So let's solve for x. 3x is equal to, the minus 1 to the other side was going to be what? A positive 1. That's a 7. 6 plus 1, that's a 7. Divided by 3 here. So that's, we're going to have the value of x, which is what? 7 over 3. As direct as this, guys. Okay, we see it. As direct as this one. Just revise as many questions there. Same application here. Can we have these numbers in the same base? Yes. This is 27, 2.14. This is 27 to the exponent of x minus 2. And there is an 81 to the exponent of 2x plus 1. So we can have these guys in the same sense. 27 is equal to, then shift fact. Where am I pressing this other one, guys? All right, no problem. 27, that is 3 to the exponent of 3. Anyways, that's here 3 to the exponent of what? Of 3, but being raised to this one. x minus 2 originally that you're given there. 81, you do the same thing, guys. This is 3 to the exponent of 4, guys. You're supposed to even know these exponents, guys. Yes, the calculator is there as an assistance. As we are answering, we know that there will be a lot of things in exam, this and that. So this is it. So we can see that there is an exponent. The bases are the same. We can even take it from here, guys. What is the concept? What is the concept? As long the bases are the same, if you can see it from here, take it from there to say this is base of 3. This is also base of 3. They're the same. So what does it mean? The remaining part of our exponents is the same. This one, 3 here, whatever that you're going to have. Remember your laws of exponents. You can also do that. Or you can apply the laws of exponents to say, okay, I see that there is an exponent and there is another exponent. So I'm going to multiply, just present it like this. 3 to the exponent of 4 into what? Into 2x plus 1 like this. At least we can say this one and this one, same bases. So therefore, the exponents that we are seeing, 3 into x minus 2, must be equal to 4 into 2x plus 1, as we can see it here. So that's it. Expand your brackets and simplify. 3 times x, that's 3x. 3 times negative 2, that's negative 6. 4 times 2, that's 4x. 8x, 4 times 2. 4 times 1, positive 4. All right. Anyways, guys, let us just quickly try to simplify some of these stages. I'm going to just try to quickly solve. Some of you complain, you are taking much time solving this question. But guys, we need to explain this so that you also understand what is happening. The minus 6 to the other side was going to be a positive 3 minus 8, which is minus 5x. And this was going to give us a positive 10. So simply divide by negative 5, both sides, you are done. So that is the idea of answering this question, guys. Just do as many questions as you can. If you have got a question, guys, the comment section is there. Let's communicate. And also, you see, guys, ask if you want to ask. Like, you see something, guys, ask that part so that we know, guys, how to assist each other. Because if you do not ask and think that we'll prophesy to say, okay, there's a problem like this that you're facing, guys, it's not going to work. Let's use the comment section to ask. There's a topic like this. There's a question like this. Oh, if you can't explain it, then come to the WhatsApp with that question so that we bring it back to you on the YouTube. Guys, it's learning. This is environment for learning. All right, let's solve this one and represent the solution in the interval notation. All right, let's solve first. Negative 2. All right. No problem. Let's have it from here so that you can properly understand. There is a 4x plus 2 there in the middle. So separating from that, 4 plus 2x. Not 4 plus x, but 4 plus 2x. It is what? Greater than minus 2, but the same is less than or equal to 6. So we are going to solve, guys. As we can see, there is a 2x and a 4 there. So let's get rid of the 4. Remember, I said we can solve this simultaneously at the same time. We take the 4 to this other side. It was going to be a negative. We take it also here. It's going to change. The sign as it is going to change. So it will be minus 2 minus 4. We subtract it this side, right? That's going to have 2x in between, less than or equal to, with the same 4. If we take it there, it's going to subtract again, minus 4. So this is where we are. And we can simplify minus 2 minus 4. That's minus 6. So minus 6 here, we have got a 2x. Then there we're going to have what? A 2. So this is it. We will need to find x. So simply divide by a 2 here, a 2 here, a 2. And take note, we are dividing by a positive. It does not affect anything. So x is greater than minus 6 divided by 2, which is minus 3. All right. 2 divided by 2, which is a 1. Does not affect anything. And they said in interval notation, how are we going to present our final answer? Simply means our x is an element of being taken from -3 to +1 as it is, like that. All right, where x being an element of what? All the real terms, the real numbers. Guys, your inequalities, when it is like this one, guys, you're supposed to jubilate in exam, take your marks. When it is like this, it's not that much. This one, it was not that much. Solve this simultaneously, x and y. Okay, I'm gonna take 2 of my equations for 5 marks. Okay, let's see. 2.3. That's our question 2.3. I'm just gonna try to reduce a little bit, guys. You know our boards, guys. So this is 2.3. So on question 2.3, we were given 2 equations there. The first one, that's x plus 3y minus 5, and that's equal to 0. I'm gonna call this our equation 1. And equation 2, we have got 2x minus 6y plus a 2, which is also equal to 0. I'm gonna call this equation 2. So in our syllabus, guys, factorization, working with simultaneous equations, the use of the substitution method proves to be the best way that you can ever have. Yes, you can use those elimination where it is easier to eliminate. But in this case, we can simply work with one of these equations. Is it equation 1 that you want to work with, where you can make x the subject or you can make y the subject? Is it equation 2, where you can make x the subject or you can make y the subject? So making x the subject from equation 2 was going to be easier. From equation 1 was going to be easier also. All right. So in this case, I'm going to work from equation 1. So from equation 1, I'm going to make x the subject from equation 1. Let's make x. We're going to take these terms to the other side of the equation. So it simply means x is equal to what? If we take the positive 3y to the other side, it's going to change to a negative. If we take the negative 5 to the other side, it's going to change to a positive. So this is the equation that is going to be our equation 3, where x is the subject. So like I said, guys, you could have even worked with equation what? Equation 2. It was easier to make x the subject. Look there in equation 2. 2x is equal to minus 6y to the other side, that's a positive. 2 to the other side, that's a negative. So as you can see, there is a 2. Yes, so you're going to divide by 2, by 2, by 2 each and every term. So x is equal to 3y minus 1. From equation 2, you could have done that. So it was up to you. So if you are working from equation 1, this is how we're going to have. So what are we going to have? We substitute this, our equation 3, into 2. Remember, we made the subject from equation 1. Don't substitute where you made the subject. It will neutralize your question. You won't find anything. So you substitute into the other equation. So we're going to substitute into what? Into equation 2. So let us, because we are using substitution method, like I said, guys. So substitute equation 3 into what? Into 2. So that's it. Into 2. In place of x, where we see the x, here, this x, we're gonna place this one. We place this as it is in place of x. You put this as it is. You're gonna put this. So what does it mean? It simply means we were going to have 2 into x. Sorry for that. Okay. So we were going to have 2 into x. Our x is this. We put back that as it is, minus 3y plus 5 as it is, minus 6y plus 2 as it is. It is remaining. There's nothing that we can substitute there. There's nothing. We have an equation of y. We do not have x. It's only y that we have. So we can solve this equation expanding of brackets as we had before. Remember, your expansion of brackets, the 2 is going to multiply everything in this bracket. So what are we going to have at the end? Let's multiply 2 times negative 3. That's negative 6y2 times 5, which is positive 10. The rest as it is, minus 6y plus 2 is equal to 0. So we can even collect the like terms as we are solving. So there is a minus 6, a minus 6. That's minus 12y. 10 plus 2, that's a positive 12, and that's equal to 0. So you can solve for y by taking the 12 to the other side of the equation. So it's going to be negative. So that's negative 12y is equal to a negative 12. It will become a negative on the other side. So divide by negative 12, guys, you're done. To have this y there, what is affecting? It's a positive. It's a negative 12, a product. So divide by what? By negative 12. So you cancel this. That's y is equal to what? A positive 1. So this is how we're going to have the value of y. Y is positive 1. And with this value of y, we bring back, substitute there into any one of these equations. Equation 1, equation 2, equation 3. But as you can see, equation 3 is the best because already x there is the subject. So I'm going to take equation 3. Just like that. So substituting back into equation 3. So from equation 3, we had x is equal to what? Minus 3y plus 5. Remember? So you're going to substitute the value of y that we calculated. So that's minus 3 into 1 plus a 5. We can even use our calculator there. So that's minus 3 plus 5, which is what? 2. That's a positive 2. So like I said, guys, you can even use a calculator. You're done. That's solving. You have solved, guys. Writing these as points, it's up to you, guys, to say, I'm going to write as a point. X is 2, Y is 1 as a point, XY. That one is up to you. There we are done to say X is 2 when Y is 1. Just like that. So you make sure one equation, you work from one equation. Make either X the subject or Y the subject. Substitute it into the other equation. You can solve from there. All right, let's consider another part again as we have this part of our equations. On 2.4, we are given the difference between two numbers is 5. The difference between two numbers. So this one I'm gonna try have it here because we need the state to properly see the statement here. So they are saying the difference between two numbers. We do not know the numbers. So let us just say the smaller one is X, the larger or the greater number, because as you are having two numbers, you must compare. So let X be the smaller number, be the smaller. All right, the smaller number, just right. I'm just going to have it in short, guys. And if we let this, it does, what does it mean? And Y be the larger one or the greater one or the greater one, which is the greater number as we are having our numbers there. So at least it can help us to simplify. The difference between two numbers is 5. The difference between two numbers. So definitely to get a positive 5, it must be greater or bigger number minus smaller one. To have a difference of 5, positive, it must be greater minus bigger. So that's what you're told there. Bigger value or the greater value minus the smaller one. We are supposed to get a 5 because, guys, it's a positive value. We cannot get a negative from that. But if we say smaller minus bigger, you get a negative. So it cannot be X minus Y. It's supposed to be Y minus X, according to how we mentioned that this one is our bigger, this one is our smaller. Then they are saying on the other part, 6 times, whenever you're given the word times, multiply. So they are saying 6 times the smaller number, which is X. So 6 times X is equal to 4 times times the greater number. Our greater number is what? 1. Guys, whenever you see these terms, multiply. So they're saying these two, they are equal. 6 times the smaller number, 4 times the greater number. They're equal. So 6 times x is what? 6x is equal to 4 times y, which is what? 4y. So this is what we are given. And with these two equations, we are asked to find the numbers. Guys, we have formed 2 equations here. And these are simultaneous equations, just like the previous case that we had. We can solve these equations simultaneously. How? It's going to be up to you. So as for me, I was going to simply use substitution method. From 1, I'm simply going to make y the subject or x the subject. It's up to you. But y was going to be easier because I'm just going to throw the minus x there to that side. So make, all right. So from equation 1, make y the subject. So I'm just gonna throw this, the negative x to the other side of the equation. If I throw it there, it means y is equal to what? 5 plus x. Already there's a 5 there, so the minus x will be positive there. So I have formulated another equation, which is 3. And I'm just going to substitute my equation 3 into the other equation, into equation 2. So that's it. Sub 3 into what? Into 2. So where we see the y, we're going to put 5 plus x. Wherever we see the y, we put 5 plus x in place of y there. So that's the concept, guys. So let's take our equation and see how it's going to be like. 6x is equal to 4y. That's 4 into our y, which is what? 5 plus x. Just like that, guys. You are done. Expand your brackets. You solve for x as usual. So what were we going to have at the end? The 6x is equal to 4 times 5, which is 20. 4 times x, which is 4x. So collecting your like terms, this to the other side, we're going to have a negative there. 6x minus 4x, which is 2x, is equal to 20. So divide by 2, that's what? Our x was going to give us a 10. But remember, simultaneous equations, where we have this equation y as the subject, we can simply substitute the x that we calculated here. So remember that y is equal to what? 5 plus x. So y is equal to 5 plus our x, which is 10. So y is equal to 5 plus 10, which is 15. So therefore, the numbers are 10 and 15. These are the 2 numbers. So you can conclude as a statement, therefore, the 2 numbers are what? 10 and 15. Just like that. So these are word problems that we form, that's going to formulate an equation from there, from words problem that you'll be given as a statement. Then you put that into an equation which you can use to solve whatever that is missing, but let unknown values be represented in form of x, y, or whatever that you have. And according to the way that they're given, are they odd numbers? Are they even numbers? Are they in a consecutive manner? It just depends with the question that you are given there. On another part, you are given that if P is this and Q is this, therefore prove that Q is equal to this, Q. So as you can see, guys, it's about Q being equal to Q on 2.5 is originally 1 plus 3 to the exponent of minus x. This is our Q. So P is given as what? P is given as 1 plus 3 to the exponent of x. So it simply means wherever we see this 1 plus 3 to the exponent of x, we just put a P. We do not see it here. What can we do? Let's simplify because it's written it's Q is equal to. So we are supposed to have it from Q. From Q. This is how we are supposed to have it from. So from Q, what do we have, guys, from our Q? Because we are supposed to prove that this is the same. So Q is equal to 1 plus 3 to the exponent of minus x, which is same as 1 over 3 to the exponent of x. Remember, how do you get rid of this? How do you remove the exponent? I mean, negative exponent there. So from our addition, we can combine this to be a single fraction. Remember, we can have our LCD as what? 1 over 1. So we can have our LCD as 3 to the exponent of x. We divide this one to 1, it remains as it is, times 1. 3 to the exponent of x plus this one and this one divides, we got to 1. So this is, we've got 1 plus 3 to the exponent of x. If we can see it properly, we have that concept here. This is what we are having. This is what we are having here. Remember 1p, and we said p is 1 plus 3 to the exponent of x. What about 3 to the exponent of x? It's written as what in terms of p here, because we can see that there is a 3 to the exponent of x. 3 to the exponent of x from here, if we make it the subject, it's going to be what? P minus 1. If we check this to the other side, p minus 1 is equal to what? 3 to the exponent of x. So wherever I see a 3 to the exponent of x, it is same as what? P minus 1. So therefore, guys, we can conclude here that this is equal to, we can conclude that this is equal to 3 to the exponent of x plus 1. 3 to the exponent of x plus 1. This one as it is. It represents what? It represents p over what? 3 to the exponent of x. It represents what? It represents p minus 1. So this is exactly what we are having, which is what we are being asked to show or to prove. So this is exactly what we have here on our other part of the equation. So this is how these questions can be simply evaluated or simplified as you adjust into the simplification, but only that on that simplification is just like you are to prove, you see. You are to prove, but idea still the same. So on question number 3, we are simply given, this is a right-angled triangle, all right? A right-angled triangle with sides P, Q, and S, all right? The angle theta as shown below. So this is our right-angled triangle, guys, as we can see, our sides and everything. And from this diagram, they simply need us to find these ratios, all right? So guys, simply know the SOHCAHTOA concept, all right? Remember our SOHCAHTOA concept. All right, what do we have? The sine, opposite over hypotenuse, cos, and tan, this concept. So here we are given, according to theta, we name the sides according to theta. So according to theta, this side that faces theta is the opposite. So we have got our opposite, theta and 90 degrees. They are sitting next to each other here. So this is your adjacent. And definitely the longer side, which faces the 90 degrees, is our hypotenuse, this one. So this is it. So we are going to fill in, then we answer our question. The first one, tan. Remember, tan, opposite over what? Opposite over adjacent. So according to here, opposite is S. Our adjacent is what? Is Q. So that's S over Q. The other part that we are given on B is negative sine of theta. So that's negative of what? The negative of sine opposite over what? Opposite over hypotenuse. So you're going to have negative of opposite, which is S, over the hypotenuse, which is what? Which is P. Just like that. So this is how you answer this question, direct like that, guys, all right? Then the sec squared, all right? Sec squared theta. Remember that the sec, as we do understand, it's 1 over sec. 1 over cos, opposite there, 1 over cos. So if it is 1 over cos, what does it mean? Cos is adjacent over hypotenuse. So once you say 1 over that is the reciprocal, so it will be hypotenuse over adjacent. You interchange hypotenuse over adjacent. So when we say the sec is hypotenuse over what? Adjacent. But they are saying sec squared, we must square it. Hypotenuse over adjacent, we must square that. What is our hypotenuse here? It is P over the adjacent, our adjacent here, which is what? Which is Q. But we must square this. So what are we going to have at the end? If we square this, everything will be squared. P will be squared, that's P squared. Q will be squared, that's Q squared, like that. You're done. You are done, just like that. All right, so that is it, guys, on answering this question. Then we are given here, if that's an, you are working from that value that you're given. So they're saying if it is given that P is 12, the only part that they gave you there is what? P, which is 12 here, our hypotenuse. They gave you that P is what? Is 12, this one. And theta, this angle is what? 35 degrees. The angle. Calculate the numerical value of what? Q. Find the Q, this one. Given this information, find the Q. So we are not worried about knowing about this S or the opposite. We just need to focus on these two. So that's how you answer the question. Use the ratio which is what you are given. You are given 12, which is the hypotenuse. And you are asked to find what? Adjacent. Is there a ratio of this that has got what? Adjacent, hypotenuse at the same time. Adjacent hypotenuse at the same time is there on a cos. So we are going to use the ratio of a cos to answer this question. So how do I take that ratio of a cos? That's 3.12. I write down my ratio. The cos of theta is written as what? Adjacent over hypotenuse from here. So I substitute what I'm given. The cos of what? Theta is what? 35 degrees is equal to the adjacent. What is the adjacent? The one that I'm being asked to calculate, which is our Q, over hypotenuse, which is the one that we are given, which is 12. So the question is, what is going to be our Q? As we can see, guys, we can simply calculate our Q, cross multiply here. That's going to be our Q. 1 times Q, that's Q is equal to 12, multiplies cos. So that's 12 cos of 35 degrees. So that's it. We're going to have our Q from there. So meaning to say, that's 12 cos of what? 35 degrees, like this. So that was going to give us 9.83 to 3 decimal places, or you can shift, set up, fix on number 6, then press 3. It's going to be 9.830 to 3 decimal places. Why did I press 3 decimal places instead of 2 decimal places, guys? I need 2 decimal places there. 9.83. All right, so that's it, guys. We're gonna have 9.83, or just round off, guys. Direct. It's not there. It's not like to use a calculator is the only option. There, I'm just showing you guys that you can use your calculator if you do not understand how to round off your values. Therefore, just use your calculator in that simplification. You won't even go wrong. All right, so guys, we just have to be careful in your simplification. All right, so let us consider anyways another part of our question here, which is also to evaluate, but this time we are supposed to use our calculator. Use your calculator to evaluate the following: correct to 2 decimal places. Our answers are supposed to be to 2 decimal places. We are already given these values. Just substitute sine A plus B. Our A is what? 20 degrees. Our B is what? 55 degrees. So that is it, guys. We're going to simplify. You can even add 20 plus 55. That's 75 degrees. But remember, they said use your calculator. So just take your calculator. What is sine 75 degrees, like this? So that was going to give us, right? They said to 2 decimal places. So fix your calculator to 2 decimal places, 0.97. So that was going to give us 0.97 to 2 decimal places. All right. So that was it, guys. Like that. Tan squared of B on 3.22. The tan squared of B is the same as tan B squared, like this. That is what it means. That is what it means. So we have the tan of B. What is our B? 55 degrees. But that must be squared, all of it. So as you are simplifying, you open a bracket first. Then you simplify tan 55. As you can see, there is a bracket which is already opened. Close that one, then close the first one that you opened. Then you square everything. That is what it means. 2 point what? 04 to 2 decimal places. So that's 2.04. Just like that. All right. We move on to another part. That's 2 cosec of A. Remember, cosec, 1 over sine. So it simply means 2 times 1 over sine cosec, 1 over sine. So that's 1 over sine of A plus sine of what? 5B. All right, so let's put our values 2 into 1 over the sine of A. What is our A? 20 degrees plus the sine of what? 5B. So this is our B, which is what? 55. So that's 5 times our B, which is 55 degrees. So that's it, guys. We can even use our calculator like this. Yes, you can simplify this value on its own, this one on its own. But remember, they said use your calculator. So just open a bracket, 2 into what? 1 over sine of what? Sine of 20. Close this one, then close the first bracket. Plus the sine of what? 5 times 55. You close that bracket as it is. So that was going to give us 4.85 to 2 decimal places. All right, so that's 4.85. Just like that, we are done. So that is it, guys. On the other part of our question, which is question 3.3, we are given without the use of a calculator, guys. Showing all working, determine the value of without the use of a calculator. So they want you to apply your special angles when it is like that. So know your special angles, guys. I'm just going to have this in short. But like I said, your special angles, even from your calculator, guys, even if you understand your calculator. But anyways, we do understand from 45 degrees, this will be 45 degrees. We've got 1, square root of 2. Then this one is gonna be like this, 60 degrees, 30 degrees. This is 1. Then we're gonna have our 2 here, then square root of 3. So that's it. So as you can see, sine 45, according to 45 degrees, opposite over hypotenuse. Opposite, which one, whichever that one that you want. So I'm gonna use this one. Opposite over hypotenuse. So according to these 45 degrees that I'm indicating, this is our opposite, and our hypotenuse is not affected, and this is our adjacent. So we need opposite, which is 1 over what? Hypotenuse, square root of 2 times tan 60. This is tan 60, 6 squared. So you're going to have tan, remember, tan from our tower, opposite over adjacent. So according to 60 degrees, here we have 60 degrees opposite. Just like this triangle, remember where 60 is same way 45 is. So the opposite is what? Square root of 3 over what? Adjacent. Our adjacent is this one, which is 1. So it's opposite. This is going to be our adjacent according to 60 degrees. So our adjacent is 1, but it's being squared. You square this. Everything over what? Cos 45. From here again, cos 45 from our SOHCAHTOA, adjacent over hypotenuse. So that's 1 over the square root of 2. All right. So this one, there's only one part here. So it's just 1 over square root of 2 plus the sine of 30. According to this diagram, we have to change because we are now relating to what? To 30 degrees. According to 30 degrees, this becomes our opposite. So we need sine, opposite, and what? Hypotenuse. Remember, sine, so opposite over adjacent. So our opposite is 1, and our opposite over hypotenuse, guys. This is being tired. The mind is now tired. Opposite over hypotenuse, which is what? 2 there. So that's it. This one and this one, because there is a product and this is a fraction, you can cancel. So we're going to be left with square root of 3 over 1 squared. Square root of 3 over 1, guys, any number as we have it over 1 is just going to remain as it is. So it's square root of 3 as it is squared. So you're going to have as it is squared plus what? Plus the 1 over 2 that we are having here. So what is the square root of 3 squared? The square root of 3 squared, a square root and a square neutralizes. So you remain with 3 plus 1 over 2. And 3 plus 1 over 2, a whole number. Adding a fraction, we're just going to combine 3 and a half like this. So that is how you're going to have your answer as. So they said just determine this value. You're not given instruction. Is it going to be as a decimal or what? Just leave it as it is. You can have it as a decimal. It's in your hands. It's your choice. So guys, do revise as many questions as you can as you are preparing for the tests and also exams ahead of time. So this is it, guys, till we meet again.